So we've got this 2 by 2 system of equations, and instead of using elimination or substitution method, we're going to use matrices. So first of all, you represent the problem, the system, in a matrix without using x or y. The first row are the numbers 2, 3, and 1, so I'm just using the numbers without the x, y, or equals. The bottom one, now essentially what we want to do is something like elimination method, but at the end our matrix should look like this: 1, 0, and then whatever we get here, 0, 1, and then whatever we get here. Because this is going to say you've got 1x, 0 y's, and then it equals this number. So that means that x is equal to that smiley face. And then this says you've got 0 x's, you've got 1 y, and it equals this guy. So that means this row is going to say y is equal to this kind of smiley face. There's only 3 rules, and that is you can multiply a row by a number and then add it to the other row. You can switch 2 rows. Well, actually, I combined the first 2 rules. The 3 rules are you're allowed to multiply anything, any row by a constant. The second rule is you can add one row to another. We usually just combine those 2, but they're technically 2 separate rules. And if you want to, you could switch rows. In other words, you could take this row, make it the top row if you want. Okay, so then what I'm going to do is use this -1 to cancel out that and get a 0. So the real goal is in here, get as many zeros as you can to simplify it. So I'm going to take this, multiply by a 2, and then add it to that and cancel it. And in between, I even write down what I'm doing. Take 2, multiply it with row number 2, and then add it up to row number 1. So this multiplied by 2 is going to be a -2. Added to that is a 0. Multiply this by a 2 is a 4. Added to that is a 7. Multiply this by a 2 is 8. Added to that is 9. And then the bottom row stays the same. So we use this operation to change the first row, but it doesn't actually change the second row. Okay, keeping in mind that I want these things in here to be 0s and 1s, I can get this to be a 1 just by dividing. So the next step is multiply 1/7 times row number 1. So row number 1 now looks like 0, 1, 9 divided by 7. And I'm still not changing the second row yet. Okay, now I'm ready to change the second row. Now, like I said, the goal is to get 0s and 1s in here. At the very end, I want them to be in this order. 1, 0 for the top row, 0, 1 for the second row. I can change the order later on. Right now, I just want to get these 0s and 1s in here. So, the 0, 1 part, I've got that, 0, 1. Now, I need this to become a 1, 0. So I can use this 1, multiply it by a -2, and add it to this, and it'll cancel that. So that's the next step. Take a -2 times row number 1 and add it to row number 2. So row number 2 would look like this. So multiply this by a -2, that's 0. Add it to this, it's -1 still. Multiply this by -2, add it to this, it's a 0. Multiply this by -2 and add it to this. Let me get my scratch paper back here. So multiply this by a -2, so -2 times 9/7, and add it to 4. So this one would be -18/7 plus, if I make this 7/7, that's going to be plus 28/7. And that is a grand total of positive 10/7. So 10/7. Okay, so the one you're adding it to is the row that gets changed. The other row stays the same. And then this right here needs to become a positive, so I need to multiply this row by a -1. So -1 times row 2. Don't you just love math? And finally, switch the rows, because it's supposed to go 1, 0, and then 0, 1. So take this row, put it up on the top. So row 1 gets switched with row 2. So 1, 0, -10/7 goes to the top row, and 0, 1, 9/7 goes to the bottom. So this one is saying that x is equal to -10/7, and this one is saying y is equal to 9/7. Or if you write it as an ordered pair, the point where the two lines intersect is at -10/7, 9/7.